Today we're going to look at symbolic logic, which is a way of determining the truth of a compound, often very complex sentence. We won't get to the super complex ones. I took a logic class in college, and one of the things we did were enormous compound statements. It's like, when is this statement true and when is this statement false? It was interesting, and I thought it was actually kind of fun, but I like geometry, so it kind of made sense to me. So a compound statement is created by combining two or more statements. So the two primary kinds that we haven't talked about before are a conjunction and a disjunction. Conjunction is where you're joining two things together with an and. So it's true only when all of its parts are true. In words, that's written as P and Q. You know, P is a statement, Q is a statement. We're saying they're both true, if this is true. Symbolically, the way that we write it is P, and this is the symbol for a conjunction. The way that I remember it is it looks like a capital A without the bar, right? And A stands for and. Then a disjunction is a compound statement using the word or. It's true if any of its parts is true. So if we're looking at P or Q, and all we do is we take the symbol for a conjunction and flip it over, and now that's for disjunction, P or Q. So let's take a look at these. Just so we all are on the same page to start with, let's look at the truth value for my original statements. Austin is the capital of Texas. True. Pecans grow on trees. True. What's the nut that doesn't grow on trees? Peanuts. Peanuts are legumes. Very nice. They actually grow, it's almost like a bush, they grow underground, a little bit like potatoes. And animals with wings can fly. A penguin would be a counterexample. What other counterexamples could you think of? Pardon? Ostrich?
Can roadrunners fly?
That's a great question. I don't know.
Because they run,
Yeah?
but I don't know if
Peacock,
they can
wait,
fly.
do they? They don't have wings. They have the pretty thing.
They have wings.
They have wings?
Yeah.
They can fly.
Just, yeah, peacocks can't fly very well, but I think they can fly. A little bit like chickens can kind of fly, but not very well.
You're wrong. Chickens can jump and flap their wings.
Yes.
I would think
Geese.
roadrunners can fly.
I don't know if for kiwis can't fly.
Kiwis can't fly?
Nope.
What do they do?
They walk.
Oh, that's boring. Such for them. Wait,
That's so sad.
kiwis?
Yes,
They're like, I thought they were like tiny little birds.
they are.
What? I thought a kiwi was a
Penguins
fruit.
are birds too. They can't fly
They're
either.
big.
Oh no, some penguins are like tiny.
Guys, I'm lost.
Now I feel sad.
Okay, kiwis are also birds.
Have you considered converting to a different religion?
What the hell?
She said she was lost.
What's that? What's that?
I gotta
But now
stop
I'm
and do it.
found.
You're not
Just
funny.
staring at me.
You trying to think of another bird?
Yeah. It might not be a bird. Flamingo.
Flamingos can fly.
Swans.
Swans can absolutely fly.
Flamingos can definitely
I think
fly.
of
You
a
know,
bird.
you've never watched
Yeah, I'm
like
just thinking of like
an
a
like
fat
And I
baby
know what it
mockingbird.
is.
the Lion King.
I think
like,
it can fly though. It's the animal of Japan.
Don't know what
The
it's called.
animal of Japan,
Your
the
national
animal
animal
of
Japan.
Japan.
Like national animal thing?
like a crane.
No, it's a type of bird.
Crane.
A crane is a type of bird.
Crane is a type of
All right.
I know.
I know which one.
Yeah.
I don't know which one you're talking about, but I want you to find that because I'm interested to know. All right.
I didn't know that
Yeah, kiwis are birds.
Because I eat birds.
No, there's a kiwi fruit, and there's a kiwi that's a bird.
That's what I was trying to tell you, but you weren't listening.
Yeah, because I don't.
Yeah, you don't ever listen to him. Anyway,
It's like
so let's take a look at this. So this is Q disjunction R, or most of the time people just read it as Q or R. Is that true or false?
True.
True, because I just need one of them to be true. It doesn't matter that R is false. What about P conjunction R, or P and R?
False.
That's false because,
Because not all the parts are true.
yeah, because not all the parts are true. All right, this one, R, what does that arrow means again? How do you read that?
R.
If
If R, then Q.
All right, so you can read it as if R then Q, but what does this one word stand for?
That
Starts with an I.
if intersect.
M,
M.
P,
IMP. Implicates.
shorter than that, implies.
Uh,
R implies Q. So that's if R then Q.
If animals with wings can fly and pecans
No.
True.
on trees.
This is true.
Because if the
Remember, if the hypothesis is false,
Oh, right.
you can't prove that I lied.
Right.
Okay? Right? If I don't win the lottery, it doesn't matter whether I give you the $1,000 or not. You can't prove that I lied. All right. For this symbol is for negation.
oh, so like the negative of it
So not.
would not go for both or just the P.
It only applies to what's directly behind it. That's an excellent question.
Okay.
So this is not P or Q. So not P is false, right? Because P is true, not P must be false. Or Q, which is true,
So yeah.
so that's going to be true.
Wait.
For this is or, so either one of them is true. So this is a false or true. We only need one of them to be true. The answer is that that's true.
Wait. But P. Wait. Opposite is not the capital.
Go ahead.
But P is true.
P is true, so not P is false.
Oh. Okay.
Okay? All right, then here we have not Q, so that's false. Implies P, which is true.
True.
That's true. If the hypothesis is false, you're done. It's a true sentence. You don't have to read any more. Again, the one that I use, if I don't win the lottery, no matter what I do, you can't prove that I lied when I said, if I win the lottery, I'll give you $1,000. If the hypothesis doesn't happen, all bets are off. All right, then this one, not R, that's true. Conjunction, or and Q,
So it's
which is also true. So this is true.
wait, so would it be animals with wings cannot fly? Or animals not with wings can fly?
So when you do the negation there, it's not just adding not, it's the opposite truth value. Maybe a better way to think of it.
Got it.
All right? So let's go on to something called a truth table. So a truth table lists all possible combinations of truth values for a compound statement. For example, we're going to construct a truth table for all three of these, and we'll just do all three of them at once. We won't do three separate truth tables, although we could. So that's P implies Q, P and Q, P or Q. So there are only two parts. There's P and there's Q, right?
Right.
So we're going to have P, we're going to have Q. We need to list all of the possible combinations that we can have for true or false with that. There are many ways you can do this. Here's what I do. See if you can follow this. I take the number of objects there are, in this case 2. I take the number 2 and raise it to that power. So 2 to the second power, 2 squared is? 4. There are 4 possibilities, right? And the reason I do 2 to that power is because they're each either true or false. I'm like, okay, there's going to be 4. So I'm going to do half true and half false for P. And then I'm just going to go true, false, true, false. I now have all the different combinations that I could have. I've got true, true, true then false, false then true, false then false. Got all the different combinations. So now let's look at P implies Q. So if P is true and Q is true, is this a true sentence or not?
True.
It is true. If P is Q, P is true, excuse me, and Q is false, then P implies Q is
False.
false. That's where I told you, if I win the lottery, I'll give you $1,000. And here I won the lottery, but I didn't give you the money. That makes me a bad person. Okay? All right. What about false implies true?
True.
That's true. If the hypothesis is false, then their statement is true no matter what. And the same is true for the last one. All right, let's do P and Q for the conjunction. P conjunction Q. What has to be true for that to be true? Both parts have to be
True.
true. So what's the only one that's true out of this list?
The first one.
The first one. Everything else is false. And then last we have P disjunction Q, which means
That only need one part needs to be true.
P or Q, we only need one part to be true. So, which ones of these are true?
All of them except for the last one.
Yeah, the first 3 or all of them except for the last one. All right. Any questions about that? Let's do one that has 3 parts. So since it has 3 parts, I'm going to do 2 to the third power. That's 2 times 2, which is 4 times 2 is 8. I'm going to have 8 different possibilities now. You can see how this gets crazy if you have a lot of different things. So I need to have P, Q, and R. And I need to have all the different combinations. Like I said, there's a total of 8 combinations. So what I'm going to do is start with 4 trues, 4 falses. You don't have to do it in this order. I just think it makes it easier. I didn't draw my lines quite long enough. Boop. And then since I've done 4 of each, now I'm going to cut it in half each time. I'm going to do 2 and 2. So 2 trues, 2 falses. 2 trues, 2 falses. And then 1, true, false, true, false, true, false, true, false. If you do it this way, you'll get all 8 combinations. And selfishly for me, it makes it a lot easier for me to grade it because yours will be in the same order that mine will be in. I have had students in the past that sometimes just think their way through all the different possibilities. It takes longer to grade, but it's not a big deal. All right. You must start with the regular. Sometimes people want to start with not P. Can't do it. All right. So we need a column for not P. It just has the opposite truth value that P has. So because it has the opposite value that P has, this is going to be 4 falses and then 4 trues. And then we want to join that with Q or R. Now notice the Q or R is in parentheses. That means it needs to be done before we try and join those 2 parts together. Does that make sense? It's sort of like I've got this part that's not P, and I've got this part that is Q disjunction R. So I need to do that next. Q disjunction R. What do I need from Q and R for this to be true?
Only one part needs to be.
Only one part needs to be true. So for this one, that's true. Again, I'm just looking at Q and R. That's going to be true. Next one's true. Last one's false. And then that same pattern repeats again. I've got 3 trues and a false. Now I'm ready to join those 2 together. So not P and Q disjunction R. So now I'm just looking at these 2 columns. I'm looking at the not P column and I'm looking at the Q disjunction R column. This is a conjunction, so what has to be true about those 2 pieces?
They all have to be true.
Yeah, they both have to be true. So looking at this, for this first one, one's false, one's true. That doesn't work. 1 false and 1 true. That doesn't work. A false and a true. That doesn't work. A false and a false. That doesn't work. And then I finally get to 3 in a row that do work.
Wait, why'd you write true for all of them?
Oh, because I'm a goober.
Okay, I was like, wait, why is he writing the opposite of what he's saying?
Like, that doesn't work.
That doesn't work.
Is it true that it doesn't work? Yeah, it's true that it doesn't work. Sorry about that. So what we would do in the class that I was in is we would go back and analyze the ones that were true. And we'd go, okay, what has to happen? P has to be false, and either Q or R have to be true. Which makes sense, right? All right, let's do one more. And that last V, I don't know what possessed me to use the letter V in this. Let's use Z. Because the V looks like a disjunction. And that's confusing. All right, so we've got U, W, and Z. So I need 8 different things. So again, I'll start with 4 Let's start with 4 trues. I'm all over the place today. So true, 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 false, 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 false. And take half of that number. So true, true, false, false, true, true, false, false. And then true, false, true, false, true, false, true, false, true, false. All right, so what should we do next?
U implies W.
Yeah, U implies W. All right, so if U is true and W is true, is this conditional statement true?
Yes.
Yeah. And the next one is exactly the same. I don't have to do any thinking about that. If U is true but W is false, is the conditional true or false?
False.
False. And this one's exactly the same. If U is false and W is true,
It's true.
that's true. That's the case where I didn't win the lottery. It doesn't matter what I do. I can still give you $1,000 if I want. This one is exactly the same. And the hypothesis is false and the conclusion is false. That's a true conditional. If I don't win, it doesn't matter that I don't give you $1,000. Now we'll do W conjunction Z. So for that to be true, both W and Z have to be true. Now let's see. Where does that happen? Here and here, and everywhere else it's false?
Yes.
And then we'll combine those. U implies W, the conditional statement, or W and Z. So only one of these two needs to be true in these last 2 columns before this one. So that'll be true because there's both of them true. True because one of them's true. The next 2 will be false. And the rest of them will be true. Any questions about those? Okay, then that is it for today.